Howdy doody, good morning. Good afternoon, sorry, good afternoon. Welcome to another coding session, stroke, struggle session, stroke, UPAS bring up, stroke, more on the ESP32 time zone. Anyway, without further ado, catch you in a few seconds. How do? Back again. Let's just do some housekeeping. Okay, so good. No, I won't say good anything, I'll just say welcome. Welcome all. That's it. That's all you're going to get today. Right. Okay, so I've already done a bit this morning. And I thought I'd just stream a bit more. So anyway, let's see what progress we've got going on. So anyone who's just tuned in, we've got this ESP32 web API. We're developing an addition, an extra way of inputting the time zone into the system. This particular, what you're looking at here is an ESP32 device that's serving up a web server of an interface, and we're working on the time zone at the minute. So anyway, if you're not quite sure what's going on, maybe look at some of the other videos. So we've basically got to turn this, we're turning this data here when we choose. If I choose Monday, choose 8 o'clock till 8:15, so the timer will kick on. It's just like a central heating timer or a 7-day timer. And we're going to go off at 9, just say 9:15, and the afternoon slot we're going to go at 16:45. We're going to switch back on again and got to go to 1700. That'll do. So click on save there, and it's updated the Monday slot with that info. Yeah, and we've got it set up so as you can see here, right, we can see, hang on, let's get that out of the way. I've got a returning value, so the information we just put in, it's slot A on time is 8:15. Let's just go a little bit higher. Slot A off time is 9 till 9:15. Right, so it's extracted from slot B. On time 16:45 to 1700. Yeah. So it's got the information we need to proceed to the next stage. Okay. So anyway, the next stage is we're already using our EEPROM buffer to store a time zone when sent over from. Let's just run the UPAS software. I'll give you a quick show again, in case you haven't seen anything else going on. This is a desktop software that works to update.
Welcome to UPAS.
The ESP32.
Engine 22 is now online. Engine 23 is now online.
So basically, this is how we do our time zone at the minute. Let's just get rid of this a minute. Right, okay. So we've got this is how we're doing our time zone. So we've got a user interface that you can drag and drop. So you click in there and you can scroll wheel it up and down can drag it around, and basically anywhere where there's colour like that, that's the AM, that's the FM, that's the legend. So sorry, PM and AM times 12 hours in each day. So anywhere where there's a segment of time, we've got a 1, basically a 1. Anywhere where there's no segments time, we've got a 0. So you'd expect to see from there lots of zeros, and then lots of 1s, and then lots of zeros, and then lots of 1s, and lots of zeros, and so on and so forth. Right, so from here you can have as many time zones or per day on and off periods as you like, only limited by the minimum on-off period, which is 15 minutes. So you could basically at 2 o'clock it'll switch on for 2 minutes, 3 o'clock it'll do that, 1:15 it'll switch back off again. So you can see what we need to do. So this is the way that I've done it already. It's a working way, and we want to utilize this storage method in the actual ESP. This is the desktop software keeping it in a database. And if I click save now, it's going to send, hang on, let's just show you that. So it's going to send this, if I click save now, it's going to broadcast it to the controllers. Okay. You get a bleep back, a ping back to say that it received it all and it stored it okay. So that's how we send it over. Alright, so we go the other end now. Let's click that off. Get rid of this bit. So
Thank you for using UPAS.
we sent that over to the ESP32, which if you want to see it, it's down here. These devices here. Okay. Right. So and we've got this. We're connected now to the ESP32 here. We log on to it. IP address. It's just done a reset. Of course it is. Right. So we're going to log on, and we're going to go over to settings, the time zone. So we've created this form. So the ESP32 is serving up a web server. Oh, it's web serving, and this page is serving up this form. It's showing you in the table what the settings are, the default settings are already. Okay, that's from Sunday to Saturday. These are what the two are set. Well, it's actually not showing you. This is not directly compatible with what I've just sent from the main software, because this is only showing you 2 time slots. So it's basically utilizing the structures that are in place to send the major time zone. The other time zone includes public, holiday and an event day, but we're only doing the basics here. We're doing a single zone. You got multiple time zones capability on the other software. With this one, we're just going to utilize a single zone. So we directly from the web interface or web server of the ESP32, we can serve up, change just one of the settings. Okay, one of the time zones, and we're going to just follow that time zone. This is just so we can set it up off our phone directly. Just plug 12 volts into the ESP32, connect to it via access point mode or station. Okay, if you go into settings and network, you can join your own network there. Okay. So once you've joined the network, we're in station mode at the minute there. If it was an access point mode, we'd have AP written there. and we can switch to it. You can just hold down a button on the board, and it'll give you 2 bleeps to say it's in access point mode, and then it'll give you another tone to say you're in station mode. Anyway, so we're in station mode, but you don't have to be in station mode to do all this. You could totally put this controller out in the middle of a field at a farmyard on a device, and you don't have to be connected to the internet or local area network or anything. You could totally just use this as a cheap way of interfacing the parameters off your phone. That's the whole idea. Okay, but if you want to go ahead and connect it as a station, you can do that too, and you can either run it from the main software, which keeps it all in a tidy place. But anyway, what we're trying to do is sell this product or ship it out as a standalone thing that you don't need to go to a web page and download software, or if you just want a one-off, you don't need to do anything fancy. You open the box and you get your phone out, your smartphone, and then you interface to it. That's it. Okay, that's all you need. You don't need to go and fetch other stuff. But if you want to do more advanced stuff, then you go off and fetch the other software. Okay, but this is going to be priced in such a way that it's a no-brainer, basically. I'm not going to give every facility on here because I've got the ESP32 is serving up its own settings interface. Now I don't want to include everything because that will be just use up every scrap of memory, and we'll end up with just an interface, but it doesn't actually do anything. So the minute it does stuff. It's scanning for tokens, as you can see down here. We've got an RFID reader there. I don't know whether to repeat all this, but we'll quickly show you. So we've got a token, little RFID token, 2 readers, we've got 2 controllers set up. The one's ignoring us because it's not actually got a token set up, so if we go into tokens, it'll tell us the token there. We can easily learn this token that's not on the system, so we just click on learn mode on, and it says it's learning. It'll give you live feedback. We offer that up to the controller. You can switch the learning off, you can refresh the page, and you can see you've got a new token. So because you've got a new token, it'll actually switch the relay on now. Anyway, I've done all that yet the other live streams. Okay, I thought I'd show you in case you're just looking at this one. So come back out of that into time zone. So what we're doing now is we're activating a time zone, being able to edit the time zone so we can switch the relay here. That's toggled it on directly, toggled it off, and that's impulse the same relay, as you can see it down there. So that impulses it for the egress time, or that just toggles it on permanently. So our timer will basically toggle it on permanently, depending on what we want it to do. I think just toggle it on permanently until the time zone switches off, which is these off periods down here. So it's slot 1 is on at 7:45, off at 7:15, on again at 16:45, off again at 17:15. So it's just a way of switching, programming the interface very quickly. So anyway, so let's just say I want the whole lot to be on at 9 in the morning till 5. Right, I want it open, or the relay switch from 9 till 5. So what I do is I click save that, and you've got Sunday to Saturday 9 till 5. Okay, and that's it. If you've got a second time, if you want to go on in the morning, you can go Monday to Sunday 9 till 9:30, no, sorry, 9, and it switches off at 9:30. So it's open in the morning for half an hour. Time slot 2, 5 o'clock. It's open for half an hour again. Okay, and click save, and you've immediately got your 9 till half 9 switched on and off at half 9, and the second slot is 5 till half 5. So you got 2 slots. Okay, so we're keeping it small. We're not doing the same as we do with the main software. We're just utilising the structure and everything that's in place on the controller already to do the same thing. Don't know why I've shown you that one. Right. Anyway, so we've got it to the stage where we can pass vegetables, pass variables, not vegetables. Excuse me. Got food on the brain. Right. So we're passing the vegetables to the table to show you what it's set to. Now we haven't implemented that yet. We've just got some variables set. So we do need to extract the time from there. But for now, I'm more interested in saving the time to it. And I will get to this after, how to extract the time from it. Because we're doing it in a different way. See, the other way is the main software does it all on the software sort of desktop side of it, but this is trying to do it from this side. Anyway, so let's get back to where we got to. So what I got to this morning, we've created a bit of a routine, a couple of routines called extract byte from a string, and another one, check if minute is valid. And we've got this save time zone from web server. Okay, so once the server, this is where it gets that info. When we click that save button down here, when we click save, it's going to serve up and extract all the times, and it's going to run this function. It's going to send the days of the week object or value, and then it's going to give the on and off times for the 2 time slots, and that'll go over to this function, which will do some extraction. It'll extract the string of slot on hour and put it into a byte value. So it's going to get the individual values, which are these values here. Let me just switch that off a minute. So it's going to come back with these values here. So slot A on hour and on minute, which is and then the off hour and off minute, and they do the same with slot B. Okay, so we're extracting the string representation of that into a byte. We're using a byte instead of any, for some reason. Saving on storage, so I don't know. Anyway, so we're just going to print out here. We've just printed out what we've extracted. That's what's printing here. That's what's this bit here is what the debug is printing out. Now we do a bit of a test. Once we've extracted the values, we're going to check the values, so make sure the times make sense. So and what that means is if I set my on time, right, so if I set my on time till 9 o'clock, my off time can't be anything less than 9 o'clock. Sorry, my off time, yeah. I can't switch, well I can switch it off, but we don't do it that way. What we do is we work on positive. So if it's an on, we work on time. The default, when we clear the buffer for this storage, it's going to default them to all being off anyway. So we're only interested in doing the on time slots. So it wouldn't make sense to switch something on comes first, and then the off switches after. So this basically does a little bit of a check to see if the slot A off hour is less than the slot A on hour. If not, if it isn't, see if I select that there and click save, it's going to try to do this, but it's going to return a -1 instead of a value. So it's going to exit. It's going to exit this function and return the result. Actually, going to return a -1. So we're checking both slots. So we're checking slot A. I should call that slot A really. Slot B. We're testing both of them, and as long as they're set in the right sequence, so the off comes after the on both occasions. Okay. It'll let it carry on to the rest of the function. Now we also need to check if the minute is 0, 15, 30 or 45, and if it isn't, check if valid. Actually, we're doing that slightly wrong, aren't we? Alright, so if we're a valid minute, slot A, oh yeah, that's right, yeah. So if any of these time slots, the minute value, so if that minute value there is not one of these, right, you're saying, well, you can only choose what's there anyway, yeah, but if something goes wrong or someone tries to hack the system or whatever, or the string doesn't come out right or whatever, it's a little safeguard, probably not necessary, but it's there in case the function gets supplied with data, because potentially you could put any data in here, any minute, so we need to do a check to see if it's on the 0, the 15 or the half past or the quarter to. So we're going to check each one, slot A on, slot A off for the minutes, and slot B on and off for the minutes. And if they're not set to 0, 15, 30 or 45, we're going to just return with a -1 to say that something's failed, so it won't carry on to the next stage here. Now if everything is good, if you've got your slots and the times make sense and you've got the proper minutes turning up, it's going to go ahead and clear the EEPROM buffer. And what that's going to do, it's going to actually go to this function here, and it's going to mem set up the buffer. We've got a buffer set up. Let me go to the buffer. We've got this EEPROM buffer that stores the values being sent via packet data normally. Over in the command structure here, whenever my main software sends over a send day time zone information, it'll fill the buffer up, and at the end of the send of the packets, it does a check here and it'll actually write the buffer. Okay, so what we're doing is we are clearing the buffer. So we're going to clear the buffer down with a 0. So use the memset to set all bytes in the buffer to 0. And what that would represent, if it got loaded into here, a 0 would represent that this is all blank. So if I click save on that, if I choose every day and don't select anything, it's basically clearing the buffer. It's clearing it all to zeros, yeah, which means the timer will never come on. It'll always be off. It's never got a trigger time. So once we clear there, we can then process the times for the days of the week. The days of the week is this data here. So whichever one we've selected here, this is the days of the week. So we can either choose individual days and just set that. So if I set that, for instance, 4 o'clock till whatever, and if I save it, it's only going to save Monday. Change Monday only. It defaults, beware, it defaults back to Monday to Friday, and it clears these out. So if you click save again, you're going to overwrite that setting. You've got to be a little bit careful, but you'll soon know when you try to do it. You'll think, oh, and I've just wiped that out. So if you want to do Thursday, say you just go like that, and you got Thursday done, yeah. But all the rest remained as 0. So if I was to select everything, Monday to Sunday, and just do that, they're all back to 0. So that's another way of clearing the buffer out. Okay, so that's another way of clearing the buffer, but you have to save that. Well, it would save, it would run this function anyway. Okay, so we're passing in the days of the week, so it's how many days selection from there. So we know what to do, how many to do, and we're sending it, passing in as an argument the on hour, the on minute for slot 1, the off hour and the off minute for slot 1. Are also sending slot 2's on and off minutes. So I'll go back over here. So we've passed the criteria to see if it's all valid. We're clearing the buffer. We haven't written anything at the minute. We're clearing the EEPROM buffer, which is just a byte array. Okay, let's just have a go over here. Let's just make sure we got some voice going on. We haven't written anything at the minute. We're clearing the yeah, so we're okay. We're streaming and got audio. Right, okay. Yeah, so we got to this bit. And I've copied the days of the week switch statement. They're blank at the minute, so we need to do something with them now. So basically, it's quite a complex thing to translate to. So we're breaking it down into pieces, going through stage by stage. You know, that's all you can do really, go through it stage by stage until you break down a complex problem into stages. Okay, we've got ChatGPT available if we ever want to ask it anything or help us out slightly. Okay, to maybe speed something up maybe, or something we're struggling with. And it actually did come back with memset. Use memset to clear the EEPROM after the initialization of the EEPROM. So we can set it to, you know, all 1s or all 0s from here. Now that was done from the main software before, but we needed a way to do it from the controller. So that's our way of clearing it back to 0s or no time slots. We start from a 0 or a blank sheet, and then we add the data to it. So we're going to add the individual ons and offs to it. So if the day of the week it just happens to be Monday to Friday, we need to make sure we do it for each day. So we need to sort that out. I think I'm going to do it for Monday to start with, just to be simple. Just always base it off one day until we've got a working thing. Then we can expand it to do the rest of the days. Okay. So we've sent it the info. Now the info for Monday, it might just be sent as 0, which it's got nothing to do. But anyway, we need another function now. We need to break this down, complex problem, into simple problems. So getting your head around this is a problem because you've got to constantly refer back and forth. So we just need to switch it on. We need to write the value into the EEPROM buffer at a certain point. We've already got the ability to write the buffer out in a time zone here. It's already done but this was utilised with the main software. So once the buffer was full, we're going to reuse this to write our buffer. But we need to manipulate our buffer into the ons and offs. So once the buffer's been manipulated, we can write the buffer, just execute that function there. Okay, but the problem is we don't want to do that just yet. So we need to, if we're going to concentrate on Monday for now, we've cleared the buffer. So we've set them all to zeros. Now we need to turn it to on. So we need to use these values that are in here. Right, so we've got these values in here, the slots for A time and off time. They're represented as an hour and a minute. So we need to somehow convert that hour minute. Select the bit offset. Yeah, we need to get the bit offset. Now we've got routines already for bit offsets somewhere. Yeah, we've got some stuff here that's already in use for the original code. Right, so get byte offset address from now hour. Right, so it's getting the hour. We don't want to get the hour because that'll get the time, the actual hour it is now. So we don't want that. We want to provide the hour. Alright, and it's going to come back with our offset. So if the hour is right, so it's switching. So if the hour is 9 o'clock, say, the offset will be 4. So it's going to return the offset of 4. Now we could alter this. Rather than duplicate code, we could alter this. We could provide hour as an argument instead of get hour directly. But we'd have to see how many times we're using this. I think that's probably the best way of doing it rather than duplicating. If you duplicate it, you're using up more memory. And if you ever change one and you forget to change the other, you're going to introduce bugs into the system. So let's just first find all references to this function. So we've got the initial declaration there. We've got a get. Yeah, we've got that there. Get by offset from now hour. We've got it there, but we've got no arguments being passed because there is no arguments. So what we're going to need to do is we've only got it 4 times. That's just the header. So we'd have to change that header. If we do give it an argument, pass in an argument. I think we will, because we've only got 3 to adjust. I think we'll pass in the argument. So what we'll do is we'll go back to, that's further up the list, isn't it? So what we'll do is we'll go down here to this function. Right, so we're going to alter this. Now all we got to do is get hour, pass that get hour in. So we want that is, let me find out what the definition of that is. It's an int. Okay. So we're passing in an int. So we can just do int get hour. Right, hour. Int hour. That's it. I'll tell you what, I'll just call it let's just call it hour. Right, okay. So we're going to pass in hour. So we'll have to translate that though. We'll have to keep that, copy that, and we need to go back to these and just pass in hour. So we're going to pass in get hour. We're going to go to the next one and do the same again, and the same again. And that should be about it. This will be, hang on, let's go back to declaration. Alright, go to definition, which is here. And we need to swap that hour in there. We're going to do it directly. And there's nowhere else it needs to be changed. No, not that one. Okay, but we'll need to copy this and put it into our .h there. That needs to be updated. Right, that's it. So that's updated our from now hour. So yeah, we're okay now. Yes, that should work out okay. Right, so back over to here. So we've done that. So get bot offset. So we can reuse this function without reproducing duplicate code, and that'll still function for our, and it shouldn't give us any bother. Yeah, that's all okay. Right, so we need to use that down here. So we need to get the offset from now hour. So it's going to return a offset. Now the offset is the byte position. Yeah, we've got 0 to 6, so the byte position. Don't know if this is going to do us any good actually, but anyway. Oh, so yeah, it's telling us where it's stored in the block. So let's, now we've got another one, get bit offset for now. So there's another one there. We need to sort that out in a minute. From now hour, get the bit offset. What's this one? Get the byte offset. Right, so we've got the byte offset and now the bit offset. Right, so for the hour, it's going to switch whichever hour it is. So these are all the evens, offset is 0, and all the odds is 4 for some reason. Yeah, so obviously bit 4 stores the, so I'm basically doing something clever, yeah, because I've got enough to do a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, 12 segments, and we want to do AM. Actually, it's odds and evens. I've done it as for some reason. So the evens are stored at offset 0, or the first bit in the byte, and the odds are stored at bit 4 or bit 3. So it just tells you where it's set to. So we are going to have to change that as well. We might as well change that now, actually. Let's find all references. Should have the equal amount of references, so we need to do get the hour as well. So we need to just update that as well. So we're going to get the hour, and then we're going to go to the next one. Right, we're passing in the hour, and it's coming back with a bit position. Right, it gets complicated, but if you stick to the if you follow it through, right, so we need to pass in that same item again. It's still an int. We're passing hour, and we're going to get rid of get hour because we've already got it, and that's going to choose the hour and return the hour. Yeah, so we've now avoided duplicate code and we've reutilised that same bit. We've got to just copy that over to the declaration here. Okay, so that's okay. Everything else should be right. Yeah. Okay, and if you're not sure, if you're never sure, just give it a compile and let it process for a bit. And hopefully there's nothing gone wrong, and we haven't actually used it in our new code yet, but we've converted our old code to carry on using the same idea without creating 2 new duplicate functions. Duplication of data in either database, code or anything is a way of introducing errors and bugs, so don't do it. Right. Day of the week has not been declared. Right, okay. What's going on here? Not been declared. Right, okay. Dual timer 459. Let's go down to that one. 459. Yeah, so it doesn't know. I need to introduce the struct into dual timer because that was being used over here. So if we go back to captive portal H, and I didn't do it there. We must have done it in the top. Let's have a look. Go to the top. No. Right, so anyway, we just need to introduce into, let's close. These seem to have moved around a bit, don't they? Hang on, what am I doing? Right, let's bring that down here. Okay. Yeah, so we need to include the struct for this, which is daytime struct. Is it dual timer struct? Can't remember which one it is now. No, not that one. Time zone struct, where are we? We've got a time zone struct, yeah. So zone day. No, it's not one of them. Where do we put it? I don't know where we put it now. It's easy to get lost with lots of bits of code. Right, where's our original? Hang on, let's go back to our original problem. So it doesn't know anything about that. Now this knows something about it. So how's that found it then? Captive portal structs, maybe that's it. Yeah, here it is. So we've just got to include that in our yeah, we just got to include that. Let's find out where that's included. Not there. Maybe it's included directly. Yeah. So we just need to copy that one, captive portal structs, and make sure we're in here, so it knows about the struct. I can either do it there or do it over in here. I think we'll do it here. Alright, dual timer structs and captive portal structs. Right, okay. Right, so that error will be gone now. It knows about the struct. Okay. Using Visual Studio Code and Platform IO, it uses a C++ thing where in Arduino, if you put that struct in front of all your code using in the tab, you don't need to do what we're doing here. But you end up in a mess, quite a mess, and it can actually fill up all your tabs. So anyway, seems to be a better way of doing it. Looks repetitive this way, but it's easy to find stuff. Right, let's just have a quick gander. Yeah, we're doing all a lonesome stream again, but anyway. What I should do is share it, because I'm not sharing it, am I? Let's just do that now. Right, let's share it. I'm just going to share it on Twitter. So I only share it after normally. That's not going to help people if they, you know what I mean. Right, we shared it. Yeah, what's this? Even printed custom colour product code. Tiny watch. Alright, looks like the unexpected maker's making some more watches. Anyway, right, so I've shared it there, that'll do for now. Okay, Right, let's get that back out to the main one. Right, so it's compiling now, isn't it, without any much trouble. 11 problems. No, I don't think it's finished compiling, is it? That's the last problems. Right, anyway, yeah. So anyway, welcome to a live stream. It's just me working on this product. Yes, we're okay now. Right, let's get back down to it. Oh, that's the header. Let's get back down. So it knows about the switching of the time zones now. So we've converted some of our functions. So we're going to concentrate on Monday. Let's get a gap for Monday. Right, so what do we need to do next? Let's see what we need to do next. So we're passed in, we're passed in the results from the, hang on, let's bring up the serial port again. Yeah. So we've passed in the values from the web page here over to there. And now we need to process them now. So we've cleared. So we need to get that slot. So we need the first thing we need to do is get. We don't want the bit offset. We want the hour offset first. So we need to get this one. Actually, just copy that from there. Okay. We're going to go down here now. We're going to do Monday first. So here we go. We'll just paste that in there. So we need to create an int. We need to pass in. Right, so we need to get the byte offset, so we now start creating the bits on the on bits. Right, this gets complicated, but yeah, so it's just going through, breaking it down to little bits. So we want the byte offset, so let's get the byte offset. So we're going to call this bin int byte offset. Byte offset for, it's not now hour anymore, is it? But I'll leave that the same. It's just hour. So we'll leave that the same because it shows backward, shows where it grew from. So the byte offset for, now this is going to be the on hour, right? Okay. Byte offset for on hour. So on a hour. Right, this is gets a bit, yeah. Right, so the byte offset for on a hour equals get the byte offset from now hour. We need to tell it what the hour is, so we need to find that there. That's going to be the value. Okay, so we're breaking a complex problem into smaller problems. So that's going to use that value to get the byte offset for the hour. Okay, so we know where we're going to start. That's the byte offset, but it's not the bit offset. Now, what does a bit offset do again? I forgot. Right, so it needs to know where it stores it on the odd or even, depending on the hour. Yeah, the bit offset. So we need to get the bit offset too. Right, okay. Get it complicated. That's no good asking ChatGPT at this stage. It's just gonna come back with a whole different idea. It doesn't know what I'm trying to do, basically. Doesn't know. Right, so let's just do that. So we're gonna have we've got the bit offset. So the bit offset for now hour. Right, yeah, so it's got the byte offset Now we want the bit offset. This is good, it's working out. So get the bit offset for, same again, on hour. Yeah, for on a hour equals, right, so it's going to get the bit offset, and it's still the same thing. Still the same thing. So we've got the byte offset and the bit offset, so we know where to start to put our ones in, so that's okay. Now this is for the on hour. Okay. Right, so we could easily duplicate that code now. Right, where we're going to get to. So we've got our on hour and our off hour. We've already know that we've got it in the right sequence up here. We've done our checks. So we need an off hour next, which is easy enough to do. Let's just do that again. Copy that. So let's leave a bit of a gap so we can format it a bit. So we're going to change this to so it needs to be off hour, off hour. Get byte set from now out. Now we need to say a off hour value off hour. Okay, that should be valid. So we've created four new variables, and we're basically telling it what position in the memory is the on hour start at, and what offset. So that's all information we do need. Now, do I go ahead and write that data now, or go through to the end and get all the information? So we've done the hour, but we haven't done anything with the minute yet. Now, let's find out if we need to do anything with the minute. Right. This is, it's not going to show. It doesn't mention the minute here, does it? No. Well, the minutes. Yeah, the minutes will be the amount of digits because they're in blocks of 4. So the byte offset. Right. Now we might have to look at where we're checking it here. Let's go. Oh, yeah, our bit position minute. Right. Yeah, so this is useful stuff. We probably need this again. It's a shame that we're embedded inside the main function there. That's okay if it was just used here, but if we're going to use it again, we might need to break that out into a separate function. So yeah. So we've got our address. We know where it's going to start from now hour, get hour, zone address start. Yeah. Yeah, so we don't need to evaluate it like that. So the get hour is 12. It'll do all that anyway. Just check if bit is on now, right? Yes. So we don't need to check that bit. Hang on, there's another bit going on here. Right, hang on. Check the time zone. Right, we don't need to do that. Let's keep all that the same. Check if bit is on now. Don't need to do that. There is another function there. Anyway, we need to do something with it. We need to get this info. Right, where we saw it just now, bit position. So if the minute is 0, bit position, we need this. I'll tell you what, we don't like to duplicate data, do we? So do we break out a function? Yeah, I think we'll have to. This is always going to stay the same, so we could break that out into a function. I'll copy that. So get the bit position, so we need a function, so let's put this function somewhere. Where we're going to put it? Up the top here. let's do that now. Let's make a little function. Right, so it needs to return a bit position, which is an int. Is it an int? Bit position is an int, yeah. Okay, so we do an int. No, is that going to only return a bit position? It's going to be a different position, isn't it? Depending on where it's finding it. Right, okay, how does that work then? Let's have a look down here. So we're going down here. So get the bit position. So the bit position is here. If the bit read get the hour plus the bit position is equal to 1. Bit read, don't know. So if that bit read is equal to, right, that's just testing it. So I'm not sure whether we're doing anything from there. Yeah, so it's using the bit position. Now if it's, hang on. Is it doing a bit read? Yeah, so if it's on, it's then triggering this state. If it's off, it's just triggering an off state, an off action. Bytes to read. So this isn't actually doing anything, is it? This. So look, check if the bit is on. It's just checking if the bit is on. Yeah. So the bit position can only be. So it doesn't look like we're using the full byte, does it? That's what it seems like. Bit of position anyway. So for bit position, let's go back to the other one. Alright, let's go back up to this function here. If minute, so that's checking the minute, checking the time zone. If the minute is 0, minute was checked. Check if bit is on now. Alright, okay, let's just have a quick peek at what that's doing. Oh, that's that main thing. Yeah, okay. Right, okay. So it's only going to come back with that. So it doesn't look like the bit positions. Am I using the other bit positions? I'm using bit positions. Hang on, it's gone. This is where it gets a bit dodgy. Sorry, mate. Right, get the minute. Oh, that's the one I'm writing now. So position 0 to 3. So in the byte, what's being stored at the other position? Maybe we're not using it. That's a shame, isn't it? Shame of a. Maybe I kept it simple. Decided to lose 4 bytes for. Anyway, without analysing it further and getting lost, nested into thought. Anyway, let's create that function. We'll use it as it is for now. Right, let's just create that function. Right, here it is. So int, call it get bit position. Okay, and we need to input the value int minute. Minute. Okay, so we're going to put in minute into there. I'm going to come down to here. Oops, what's happened? Blowing function keys. Okay. Right, let's get over here. So switch the bit position. Alright, so we're going to do int bit position. Okay. Alright, let's just say bit position is 0. Or make a default. Okay, at least it's got a value. Alright, so we're going to return the bit position. Bit position. What's it doing? Why can't it find that? Oh. Int, what's happened here? Int position. Alright. So return bit position. Okay, so return the bit position. So we put in the minute into it, chuck that into it, and switch whichever one and return the bit position. So we can replace that now with replace this built-in here with the actual replacement bit. We just need to include minute. Right, so that's it. We need to tell it bit position equals. That's it. We can get rid of this now. Yes. Okay. Get rid of that. Okay, so we've updated, got get bit position minute, so we can reuse that in our code down the bottom. For why, I don't know, but we need it anyway. Yeah, we need to know where to store this bit position. Okay. Right, it's time to sit up and reposition posterior. Time we got now? 22. Yeah, we're going for a bit. Let's just have a quick look down here. Okie dokie. Right. Camera's being good today. It's not. I unplugged the connector and plugged it in. It's not seemed to be freezing. It's probably just a dodgy USB connection. The oxidation, pulling it out, pushing it back in, has scratched itself a clean connection. Okay, so we're back on here. Let's give ourselves some space because I feel boxed in. Right. So we've got our byte offset for the on hour and our bit offset for the hour. And we've got our byte offset for the off hour, and we need now to get our minutes. Tell you what, we'll just put in here bit position. So we'll do an int bit position equals get bit position minute. Now it won't be minute because it'll be one of these values up here. We'll need to get the on minute or the off minute. Right, so we haven't got that yet. So get the bit offset. Oh, hang on. Why have we got the bit offset? What we're doing here? We're doing something wrong here. Oh, the byte offset and the bit offset. Yeah, that's right. So if we got the on hour and the off hour for the first time slot, and now we need to get the bit position for the minute for all those minutes. Right, let's do that again then. Let's find the minute. So we've got the on minute here. Alright. Yeah, so that's going to be one of those 4 values. Okay, so we're going to put that into there. Get the bit position for the on minute. Right, it's going to return the bit position, but we need to call that bit position for on minute, on a minute, yeah, on a minute, yeah, that's it. Okay, we need to copy that and get the same thing for the off a minute. So the bit position for the off a minute equals slot a off minute value. Yeah. So we've got the on and off minute bit position. Yeah, that makes sense. Right, okay. We need to do the same for right, so hang on, we've got 4, hang on. We've got on A and off A. Right, so where have we ended up with 4? I wonder. Is this the same? On hour, on value. Oh yeah, we're getting 2 lots of offsets here. It's getting a bit weird looking, so I think we'll rearrange some of this. Yeah, we'll put these in a bit of a better order. Right, so they make a bit more. So we've got the on hour off, the byte offsets, and we've got the bit offsets for the hour. Anyway, this is complicated, but very complicated, but if we break it down and do it methodically, it should all work. Right. Right, so where do we get to? So we've got those two, and now we're not interested in hours here. We're only interested. So yeah. So that's for the off slot. Yeah, that's why we've only got an on slot and an off slot. Yeah. Yes, that makes sense. Right. Then we need the bit position. This needs to be B slot. We haven't done B slot on the above bit. B slot. So that should return that. But we also need to do B slot here. So we need another one for B slot. Let's do B slot. Let's leave a space there. Right, so B slot. B. It's a repetitive code. So we've got the B on hour and the B off hour. Yeah, we've got them two sorted. So we left a space there. Now we need to do the bit offset for these two. Same again. I'll keep the extra space. So okay, and this formatting should look logical, and yeah. Okay. So we've got our on B hour. Yeah. So we've covered all the bases, have we? A and B, and we've got A and B. Yeah, looks good. It's easy to introduce an error if you're not diligent enough to look at it. So we've got off, B, minute, B, yeah, off, A, minute, yeah, B, off value, hour for B, yeah, on for B, yeah, off, A on, slot, yeah. Is there any duplicates? No. Looks good. Can't see anything off the back. We're tempted to group them two together. I think I will. Just take this out because we're doing. That's better. Right, so we've got the 3 slots, and then we can just have the one line between the two. Yeah. Okay, so we've extracted the bits we need. Is there anything else we need? I don't think so. So we've got to do a little bit of a for next loop now, or we don't have the for each in C++ like we do in C#. But we can do something with it. Let's see. So we've got this just working on Monday at the minute. But if you go more than one day, like Monday to Sunday, you'll just have to have the equivalent amount of days here. So we'll just keep it simple for Monday at the minute. Let's just compile it, make sure we've not got any errors along the way, misspellings or something. Yeah, this is not the changing the way something works. You know, we've got a problem already. Right, dual timer minute was not declared in this scope. Okay, where are we looking? 128. 128. Oh, I see. It's a simple mistake. Look, see, that needs to go to that. Okay. Yep. So we haven't got that. So error jump to a case label. String. Right. Let's just recompile. Don't know if that error has anything to do with that previous error. Anyway, it's nearly 3 o'clock. It's time for some food. Start in a minute. Something. Well, soup. It'll be soup. Right. So we've still got that error. 497 jump to K, so I've forgotten something. Right, 497. Okay. A jump to a case. Error jump to case label. So what have I done here? Done something. Forgotten something. Oh, I haven't put a if I'm initializing a variable, I need to put it into braces. That's what it is. If you initialize a variable within a statement or a case, switch case, you need to put them in brackets. Let's try and compile that again. Yeah, 0240 megahertz. Okay. I need to monitor the speed actually. I don't know if it's automatic switching. It'd be nice to see the speed. Right, it seems to be going now, doesn't it? Okay. Right, so it won't do anything, but I'll just see if it compiles. It compiles now, that's good. Just have a look at the memory. Used bytes of so and so. Right, okay. Yeah, we're doing alright. Doing okay. Okay, right. So we've got our data we need to generate our ons and offs. Well, we're not going to generate offs, we're only going to generate ons. So let's do a little bit of we need a bit of a for next loop or something going on now. We've got to use this data wisely. So our byte offset for the on hour. Right. Yeah, so this is just telling us where to go into the offset for the memory. So we've got our buffer cleared, all to zeros. Now it's this buffer that's going to be written to in a certain way. It's time to bring down our buffer, and the buffer is here. So we're going to need to fill our buffer up. Yeah, we need to refer to this bit. No, not that bit. Command. Right, here it is. So we need to do the same idea here for our buffer. Right, let's get back over to that. So we've got our values, and we need a buffer. We need to choose a location. So the offset will be the on-hour offset is the first offset. So right to the buffer, EEPROM buffer. This is just an array. It's not actually an EEPROM buffer. It's an array in memory, but it gets used to write the EEPROM buffer. It gets used to write to the EEPROM from an array. So it's just a buffer array for the EEPROM, but not directly the EEPROM, but it writes in the same fashion. So what we need is the byte offset for the on hour. So we'll put that in there. That'll give us our location. No, that didn't work. Probably because I didn't copy it correctly. Right, that's going to tell us where we're going to start. We did a for next loop here, but we'll put it in manually for now. And our data, buffer data. See, at the minute we're working in bits. We're going to write a byte, so that's not really what we're after at the minute. But so we'll undo that. Right, we need to push this down a bit because we're not quite ready for that yet. So we'll start here, and this is quite boring stuff actually, so I might do a bit more on this, and then this afternoon come back with another live stream. Yeah, I think we're going to do that now. We've been going for a little while, hour and 20 minutes. We'll keep that short, and we'll do a bit more progress offline or off live stream, and we'll come back to it. Alright then, so that'll do for now. Thanks for watching so far. Carry on the next instalment, maybe this evening. Bye for now.